One of the things that you see happen in a lot of woodworking shops is we've got a device for this operation and a device for this operation, and each of those devices is very task specific. One of the things I want to talk about today is the versatility that devices like this can bring to a shop. So this is a multi-purpose router jig, and it's not a one-trick pony, it's a many-trick pony. It's kind of a stable full of ponies, because on a machine like this, you can do dovetails, mortise and tenon, Copen-style doors, finger joints. There's a huge variety of operations that can be done. So to start out with, let me give you an overview of kind of how everything works here, and then you'll better understand the machine. Then we'll look at some actual cutting so you can see how that works. So obviously the router itself is mounted on top of the machine, remains in an upright position. By using a plunge router for this, we'll be able to enter and exit the work so we can start and stop cuts. Now, one of the things that's unique about the machine is that the wood is traversed using the control of the machine. So what I mean by that is I've got a chunk of cherry already clamped in place here. So as I turn this handle, I can start the motion of that wood toward the machine. So it doesn't take much imagination to figure out that if I had a cutter in the router and I plunged in for a cut, what would happen is we'd start to machine that piece. Now a good question would be, well, how am I going to locate the router for accuracy over that piece? Bunch of different options. Let's look at one here, which is a laser. So using the X on that laser, we can locate the router over the material, lock the router in position, and continue our traverse, depending on what cut we're trying to make here. Now here's another option that's pretty cool for locating everything, and that's a digital readout down here. So one of the things as woodworkers that we like to have in our back pocket is repeatability. If I make this cut today, can I make it again tomorrow or a month from now? So with the digital readout, as I move the material, you can see that in this case it's reading out to thousandths of an inch, and that is telling me the position, left or right, of the sled as it moves back and forth under the router. Now, if you like things a little more old-fashioned, kind of the analog version of knowing exactly where that carriage is positioned, is to use a cursor down here that we can direct read off of a ruler that's mounted onto the jig itself. So lots of things this machine is capable of. I'm going to walk you through just a small portion of them. What I want to do is give you a feel for how the machine works so that you can see how a machine like this might fit into your woodworking needs. Let's take a look at one way to cut a through dovetail on this machine. Lots and lots of ways to skin the dovetail cat here, but here's an approach that is pretty cool. First off, I'm going to get my material in. It goes into the jig by being sandwiched between a fixed fence and a movable clamp. Now, remember that when we traverse the material, the digital readout is telling us where we're at. So one of the things I've already done is found out where the ends of my board are, and I recorded numbers for those positions right on the aluminum. I can just erase that when I'm done, but what I haven't done yet is found the middle. So let's have a look at doing that. Laser on, and then traverse until the X is on my pencil line, the pencil line indicating the center of the board, and of course the laser indicating the center of the collet and the bit. Then I'm going to write that down. Okay, I've already set my depth of cut, so now we're ready to make a cut. So I'll plug the router in, turn the dust collection on. The dust collection evacuates right through the back of the jig itself, so cutting's pretty darn clean, and we're ready to go. That takes care of the tails for the joint, which we'll look at in just a second. Then we'll be ready to move on and look at some sockets. Like I said earlier, a lot of different ways to make a dovetail on this machine. I'm treating it like the way I would do a hand-cut dovetail. So what I did is I traced the tails I just cut onto the end grain of what's going to be my pin and socket board, and I can cut right to the line on the machine here. Now you could, alternatively, use the cursor, use the digital readout, lots of ways to make this happen. Lock my board in place. Now, I'm going to get the bit behind my work and I can eyeball my layout lines down through the machine here. One of the things I did to make a change was I changed my guides up here in order to allow me to cut at an angle. I'm cutting at the exact same angle, 8 degrees, as the dovetail bit, so that gets everything to match up as far as the angle goes, and we'll sneak up on those pencil lines using the traverse mechanism of the machine. Check our work. A little bit of fuzzing from my maple. And it's going to take just a little, there we go. So that takes care of one way that we could do through dovetails. Yes, you can also do half-blind dovetails, but I want to move on to some other things that we can do on this machine to, again, talk about its versatility. How about a raised panel for a raised panel door? That's what I'm set up to do next here. Now, a couple things are unique and pretty cool about this. One of the things you might have heard about as a woodworker is climb cutting. Many circumstances, climb cutting is dangerous to do because it's easy for a router or the work, or both, to get away from you. In this case, the material is securely held in a sled. I've got control of it by using the handle to traverse it across the bit. So here's what's going to happen. I've got a vertical panel raiser down below the router. I'm set up for my first pass on a cherry panel. I'm going to feed the material from my left to right, which is effectively going to do a climb cut with that cutter. The benefit to it, excellent surface finish. Something that we can do here. It's not something you want to mess with under a lot of other circumstances. Now, one of the things I've done is added another form of dust collection out here on the front because we're cutting on the front. So that's going to help grab a lot of that stuff that's coming flying off of that panel razor. Here's how she's going to go. Going to increase my depth of cut once the router bit winds down by advancing the sled in just a little bit. And we're ready for a second pass, and then we'll have a look at what we have in that cherry. Now to complete our raised panel, we would continue making those passes. Typically, you're getting the back of the panel down to a thickness around 1/4 inch that allows it to fit into a groove you've made in the rest of the frame. And of course, we'd want to do all 4 sides. But I wanted to show you just that part so you could get a feel for how we could handle a raised panel on a multi-purpose machine like this one. I've got a straight bit in the router. Now, visualize a table leg mounted under here. I could traverse back and forth and cut a mortise. Easy to visualize that. Here's something I think woodworkers have struggled with, and that's if you want to do loose tenon joinery, you need a mortise in the leg. Also need a mortise in the rail. Mortising end grain is tough. I'm about to do it right here. I use the laser in order to locate everything on the rail that I have in there, and I'm ready to cut. Provides a very simple way to cut a mortise into end grain, something that's difficult, if not flat out impossible, to do with most other machines in a woodworking shop. In each case, the way we've handled material here is by locking it into the machine and traversing it past the bit. Now, you might very well say to yourself, what if I've got something longer that I need to handle, longer than the traverse of the machine can take? Can do that too. So what I've done is I've mounted feather boards under the table, one to hold the material against the fence, one to hold the material up to the bottom. Then with my router bit in place, depth and positioning set, I can feed my material from one end to the other. Well, there's just the beginning of my edge forming profile coming out on my edge by increasing my cut laterally and or increasing my cut this way. I'll get more and more profile to show. The point being, there are methods by which we can feed long material past the cutter on these multi-purpose machines. So what I've done here is giving you really just a scratch the surface view of the kind of versatility that machines like this can bring to your shop. It's worth having a look to see if machines like this can help you be a faster, better, more efficient woodworker and see just what these can bring to the woodworking that you do.